Welcome to The Explainer. Today we're diving into one of the most baffling mysteries in modern astronomical history. You know, in an era where we're discovering new exoplanets almost every single day, we've grown pretty accustomed to the predictable clockwork of the cosmos. We know how stars behave, and we know exactly how planets orbit them. But every so often, we stumble upon something that just completely shatters our standard models. What we're looking at today is a true cosmic whodunit, one that had the world's top scientific minds totally stumped, forcing them to look up and question literally everything they thought they knew about planetary systems.
Right out of the gate, we need to talk about this massive number, 22%. In the realm of astronomy, this figure represents an unprecedented, frankly mind-boggling amount of missing starlight. Stars are, fundamentally, incredibly stable nuclear fusion engines. They don't just randomly hit a dimmer switch or lose a quarter of their luminous output. For a mature, stable star to suddenly drop in brightness by 22%, it's completely incomprehensible. It totally defies the standard life cycle of the stars we observe every single night.
To really put the sheer scale of this anomaly into perspective, let's think about the actual geometry involved in eclipsing a star. If a colossal Jupiter-sized planet, a really massive gas giant, passes directly in front of its host star, it only blocks a mere 1% of that star's light. Tabby's star, however, dipped by a staggering 22%. So what does that mean? It means whatever blocked that light is absolutely gargantuan. We're talking about something roughly half the width of the host star itself. A simple planet just cannot account for this. It has to be a completely different kind of structure altogether.
Section 1. The most mysterious star. Let's examine our cosmic crime scene. Tabby's star, officially known as KIC 8462852, is a mature F-type main sequence star sitting about 1470 light-years away from us in the constellation Cygnus. And what makes the story so fascinating is exactly how this anomaly was discovered. The Kepler Space Telescope essentially stared at a single patch of sky, monitoring the brightness of over 150,000 stars all at once to look for the tiny, regular dips caused by orbiting planets. But here's the thing. Automated algorithms are rigidly programmed. They often miss bizarre, non-repeating data. It actually took human pattern recognition, specifically an amazing group of citizen scientists known as planet hunters, to flag this star's wildly unusual light curves that the machines had just completely ignored.
The data these citizen scientists uncovered was so profoundly weird that it even baffled the professionals. When astronomer Tabitha Boyajian and her team finally published the official 2015 discovery paper, they were dealing with such an immense volume of inexplicable data that they actually gave the paper a pretty brilliant tongue-in-cheek subtitle, "Where's the Flux?" This cheekily earned the object its famous nickname, the WTF star. And honestly, it wasn't just a fun little acronym. It perfectly captured the genuine scientific bewilderment of professionals trying to figure out where all this stellar energy was vanishing to. Section 2. Where is the flux? Let's track down this missing light.
The timeline of these dimming events reads like a chaotic narrative. Back in 2011, there was a massive 15% dip. 2 years later, in 2013, an even bigger 22% dip. Then, years of absolute silence. Nothing. But suddenly, in 2017, smaller dips, affectionately named Elsie and Celeste, started kicking off. This erratic behavior triggered a frantic global coordination effort. I mean, when Elsie began, astronomers were literally waking each other up in the middle of the night, scrambling to point ground-based observatories all over the world directly at Cygnus A to catch the star in the act in real time.
Now, the fundamental physics of orbital mechanics tell us that a planet will transit its star like clockwork. Gravity creates stable, highly predictable periods. But the real kicker here? The light dips of Tabby's star show a complete lack of rhythm, zero periodicity.
absolutely no predictability. The chaotic nature of these events completely breaks the rules of standard planetary science, which immediately rules out a simple, single planet in a standard orbit. Whatever is blocking this light is sprawling, it's uneven, and it's profoundly chaotic.
Section 3. The Cosmic Suspects. Time to round up some theories. Like any good mystery, scientists had to round up the usual suspects based on the typical life cycle of a star system. Was it a younger star still surrounded by a primordial disk of dusty material? Unlikely, given how mature it is. Could it be a massive swarm of giant comets breaking apart on a highly elliptical orbit? Or maybe an immense debris field from two massive planets crashing into each other? Some even threw out the idea that the star had just swallowed a planet whole, leaving behind a messy trail of fragments. These were all completely logical starting points, based on what we know about how stellar systems evolve.
But here's where thermodynamics comes in and ruins the party. In astrophysics, massive destruction creates immense heat. If planets had collided, or if a star ate a world, the resulting debris cloud would be incredibly warm. And warm dust glows brilliantly in infrared wavelengths. It's like a bright flashing beacon to our telescopes. But when astronomers meticulously searched for this smoking gun infrared signature around Tabby's star, they found absolutely nothing. The star's surroundings were shockingly cold. That complete absence of excess infrared feet meant the natural planetary debris hypotheses just didn't hold up. Their alibis checked out.
Section 4. Alien megastructures. We have to address the elephant in the room. Since there was no infrared heat, it opened the door to a hypothesis that absolutely blew up the internet. Could this missing light be captured by an artificial alien megastructure? The physicist Freeman Dyson famously proposed that an incredibly advanced civilization might build a massive swarm of solar collectors, a Dyson swarm, to harvest their star's energy. I know, it sounds like pure science fiction, but scientists didn't investigate this because they wanted it to be aliens. They looked into it because an artificial structure wouldn't necessarily emit the massive heat of a pulverized planet. It actually fit the data, making it a scientifically falsifiable hypothesis that they were obligated to test. You can imagine the tension surrounding this investigation. Pointing the world's most sensitive radio and optical telescopes at this one specific star was a massive undertaking. The SETI Institute and other observatories methodically scanned the entire electromagnetic spectrum, hunting for any kind of technological signature. Deliberate radio broadcasts, powerful laser emissions, ultra-fast optical transients, you name it, they looked for it. But the results, incredibly definitive. They were met with total, unbroken silence. Absolutely no signals indicating an advanced civilization.
Section 5. The Verdict. Let's finally solve this mystery.
To truly crack this case, scientists needed to watch a dimming event happen live so they can analyze the light. But there's a catch. Major astronomical institutions rarely grant continuous telescope time for highly unpredictable events. So, we saw an amazing triumph of democratized science. Tabitha Boyajian launched a Kickstarter campaign, and the public stepped up. They raised over $100,000, which allowed astronomers to essentially rent a global network of telescopes to stare continuously at Tabby's star, just waiting for the exact moment the light dipped again.
And that continuous observation, it finally paid off. When the star dimmed again, researchers used spectroscopy to analyze the specific wavelengths of the incoming light. This gave them the ultimate smoking gun. See, solid, opaque objects, whether that's a giant planet or a vast alien megastructure, block all colors of light equally. But microscopic space dust acts like a filter. The researchers discovered that blue light was being blocked significantly more than red light. This spectroscopic data definitively proved that whatever was passing in front of the star was not a solid object, but a vast translucent cloud of microscopic material. So the mystery was finally grounded in observable physics. The culprit? Immense screens of microscopic fine dust. Current models suggest a wildly dramatic scenario. Imagine the terrifying, violent end of an orphaned exomoon. Wandering too close to the star, this massive moon gets caught by intense stellar gravity. The sheer tidal forces stretch and completely shred the celestial body, leaving behind this drifting, uneven, chaotic ring of microscopic dust. That trailing, clumpy debris perfectly explains both the erratic, non-repeating timing of the dips and the specific way the light was being filtered.
So Tabby's star wasn't aliens, but honestly, it proves something equally profound. It shows that the scientific method, fueled by human curiosity and public collaboration, can decode the most impossible-seeming anomalies. More importantly, it's a massive reminder that the universe is unimaginably vast, and even our most ordinary-looking mature stars might be hiding chaotic, violent secrets out there in the dark. If a single star out of 150,000 can challenge our understanding of planetary physics this deeply, you really have to wonder, what else are we missing? Thanks for joining me on this explainer, and keep your curiosity pointed at the stars.